everybody's here who's going to be here. Okay. Anyway, in the materials section of the course, in the current unit, Unit 9, you'll find in the folder for the week, um, the last thing at the bottom says pH, POH practice. Those are some problems that if you were here in class yesterday, you picked up. But otherwise, these are problems that you can work on during this period and also over the weekend. So at the top, it's just name these following acids or bases, just as a review of naming acids. And the sodium hydroxide is a base. Well, that's its name. You can find the ions on the ion chart. So I'll put the ion chart in this folder too, so you have a reference for the polyatomic ions. And then down at the bottom is examples that are just like the problems that I showed you how to do yesterday. So if you have a pH of 7.6, is it acid or base? And then what is its pOH? The pH plus pOH is always equal to 14. Same thing here. Substance has a pH of 2.1. Is it acid or base? And then what would the pH be? And then changing concentrations and molarity into pH, and changing pOH values into hydrogen ion concentration. So you have to change from pOH to pH, and then change from pH into H plus. And try these as best you can. And on Monday, we'll go over them in detail. The thing we're doing in class today is there's a acid and base pH activity that's just measuring whether things are acid or base using different indicators, litmus paper, uh, universal indicator, and like, yeah, red litmus paper, blue litmus paper, or universal indicator um, colors. And I don't have the activity uploaded in here yet for remote students. So for if you're remote, for now the pH and pOH practice, you can try that and work on that. There's the acid-base notes is a good way to help you with if you need help with the calculations. We'll go over them on Monday. But then it's probably going to be during third period because I have to make videos of the experiment today. I'll try to get that done during third period. Video of the different tests for all the different chemicals, and I'll upload that activity. So it'll say acid base pH and hydrogen ion activity, which is like a little lab, so you can see how the measurement values go. And then on the lab paper, you'll be able to calculate hydrogen ion concentration, and I'll give you an example how to do that like in the lab. All right, so that's that for like remote students. So really, remote students for now just work on this thing here, and I'll upload the lab thing. And if you get time to do it today, that's okay. Otherwise, it's just additional practice as to how to calculate pH and pOH. All right, so the lab paper itself, you see there's a list of things: lemon juice, vinegar, soapy water, ammonia, tap water, so on and so forth. On the lab table, so the back four lab tables have materials on them. A couple things. If you look, there's bottles that say universal indicator. Universal indicator is kind of like this greenish kind of color stuff. There's a color chart. So if you put this indicator into a solution and then what's red is approximately pH of 2, you put it in what's yellow is approximately pH of 6. So the thing is you can't know precisely what the value is, but if it looks like violet, it says 10, but it could be anything even above 10. So universal indicator gives you a relative value as to what the approximate pH is. 7 is neutral, so this stuff starts out as green because it happens to be neutral. Green is 7 on the chart. So these charts are on the tables. The other things that are on the table are there's little vials of blue litmus paper and red litmus paper. And I mentioned yesterday the trick is that blue is for base. So if you take a single strip of this blue litmus paper and if you touch it to a base, it will stay blue. Or if it's neutral, it will also stay blue. But if you touch it to an acid, it'll turn red. So if it's blue, then that's an indication that it happens to be a base. There's also red litmus paper. The red litmus paper is red when it's an acid and changes blue for a base. The reason why we have both of them is if you put something that's a base on each of these, the red will change blue and the blue will stay blue. If you put something that's acid on both of them, the blue will change red and the red will stay red. But neutral, they stay the same color. So if you put like tap water or like distilled water, both of them, pH of 7, they're just going to each stay the same color. So it's kind of necessary to have both of the papers, and the papers are completely disposable. So, you know, you can take them out to use them, and then once you dab some on it, then you just throw it in the trash. So that's how the litmus paper goes. Litmus paper is a very cheap and quick way to tell if something is an acid or base. It doesn't get you a value. So in other words, if just because red paper turns blue means the pH is somewhere above 7 up to 14, but you can't know what the actual value is. Anyway, on the tables, there is some stuff that's common. Every table has hydrogen peroxide, has vinegar, has soapy water. But the rest of this stuff, you can dispense it into the Dixie cups. So whenever you do a test, the easiest thing to do, take one of these Dixie cups, and if you're going to test like the vinegar, you know, you can put the vinegar in just a little bit, just a tiny splash, and then you could test it with each of the papers. Start with the paper first, so I could like put the blue paper in, put the red paper in. You see that the blue paper turns red, the red paper stays red. That's an indication that it's an acid. But then you can put a drop of universal indicator in and swirl it around and see what color it comes out to be. That'll give you a numerical value. They ought to like line up with each other. Anyway, most of the stuff is actually on this front table over here. So instead of doling out stuff for every table, because we're not going to you guys today, all the stuff is in those containers. A couple things, the pink jug, that's the unsweetened Kool-Aid. So the unsweetened Kool-Aid section at the bottom, that's the pink jug. And then I don't know if you ever smelled ammonia before, but you're not going to want to smell it. So don't be like taking the lid off and taking a big deep whiff because it'll knock you out. Not knock you out, but you ever smell ammonia? Like straight up ammonia? It's like the smell like Windex has ammonia in it, but it's very diluted. Straight up ammonia will tear you up. You got a congestion, it'll clean your sinuses out. So don't like huff the ammonia. Not good. Anyway, so then which of the substances are acids? Which of them are bases? What are your strongest acids? Lowest pH? What are all the bases? What are the strongest bases? And was anything neutral? Some of the things are neutral. Some things you can tell they're neutral both because the universal indicator will stay green, and because both the red litmus paper stays red and the blue litmus paper stays blue. Anyway, so you should be able to get that done this period. And the thing about the concentrations, just to give you a heads up how that goes, for example, when you have a pH of 7, that's a hydrogen ion concentration of 1 times 10 to the negative 7. If the pH is 3, the hydrogen ion concentration is 1 times 10 to the negative 3, and so on and so forth. pH of 10, hydrogen ion concentration, 1 times 10 to the negative 10. So the value for the pH happens to be whatever the exponent is on the concentration of the hydrogen ion. That's in molarity, so it's molar. All right, cool. So that's what you can do today. Have at it. Chem honors seating chart. Yeah, like the test stuff's on the back 2 tables. Full time. Aubrey, Ben. Oh, hey. I'll mark you absent. Did you see Aubrey? Is Aubrey here today? Just not here? All right. Okay, thanks. Um, so
Yeah, for the 10 water, our red one didn't change the blue. Right.
All right, so for remote students, the lab's in there now. So it says acid, bases, and pH lab. It's at the bottom. And just in a few minutes, I'll upload a video to YouTube and put a link here and also put it in the updates for the data for the lab itself. But basically, the lab has a list of common household things, and I'll test with both blue litmus paper, and if it's blue and stays blue, then it's either neutral or a base. If it's red and stays red, then it's an acid. If it changes blue, then it's a base. So basically, if it's blue and changes to red, it's an acid. If it's red and changes to blue, it's a base. But if blue and red stay the same color, then it happens to be neutral. So it's necessary to have both, because just because blue changes or blue stays blue doesn't necessarily mean that it's a base. It could also be neutral. Same thing, red, if it stays red, doesn't necessarily mean it's an acid. It could also be neutral. So if they both end up blue, then it's a base. If they both end up red, it's an acid. If they both stay the same color, then it happens to be neutral. The color with the universal indicator is based upon a chart that I'll show you. And the pH, you can estimate the pH based upon the color that the universal indicator looks like. And then whatever the pH is, you can change that into a hydronium or hydrogen ion concentration, which is the same as a hydronium ion concentration. You know, with this simple idea that the pH is 7 has a hydrogen ion concentration of 1 times 10 to the negative 7.
Lemon juice? Yeah, that looks fine. We just know like what should be like reviews that list all the substances that are acids. We put the ones that we found to be acids, like soapy water could come up as an acid for us, but like it should be alkaline, right? Go to the all flavor I mean like the two limit papers like didn't change color streak. There's like neutral, but then the universal indicator for that yellow is at like 6.9. Yeah, so it's well, so it's pretty neutral. Okay. So like if there's an awful lot of water, enough of soap, some soap is actually designed to be neutral pH. Yeah. Okay. Well, so there's the limit paper. Universal indicator of universal indicator drops. Water, soda, So if there's things that are out of accordance with each other, and better values than paper, sometimes it's clear, where it's clear that I don't know. Everyone's clear. Well, the trick is it's kind of got a little bit of a so sometimes so I have to check the vending machine.
Yeah. Ah, shoot. I recorded like as a vertical video. I can rotate it. Let's see, edit. 'Cause I held it flat. You know what I mean? Like I didn't get it right, and then yep. All right, rotate. Done.